So this is from section 1.2, and we talked about domain and range. So you asked, does the number in the numerator affect anything about the domain of a function? So let's look at number 11 here. So 9 over x minus 6. Now the two things at this point in the course that you got to worry about is I can't divide by 0. And I also can't take the square root of a negative number. So those are the two issues we got to deal with when we're looking at domain and range, again, at this point. So if x was equal to 1, say, well, actually, let's not do 0. Well, if x equals negative 1, so what if x equals negative 1? Can I substitute negative 1 into this function? In other words, can I find f of negative 1 and get an answer, or is that going to lead to division by 0? That's going to give me 9 over negative 1 minus 6, which is going to be 9 over negative 7. And yeah, negative 9/7 is a perfectly fine number. So what happens here is with the numerator doesn't affect the domain at all, because if the numerator is 0, that would be 0 divided by a number. Well, that's 0. In this case, the 9 will never be 0. So we'll always plug in any number value, except if x, what I've got to do is I've got to look at that x minus 6. We have to know when's that equal to 0, because I can't have 9 over 0. So what you do is get x equals 6. So x can't be 6. I mean, if you wanted to write it out in interval notation, we'd say negative infinity until 6, jump over 6, 6 to infinity. So x can't be 6. Or you could say x such that x is not equal to 6. That would be the set building notation, okay? So either way works, and that's when we're dealing with the denominator. Let me stop this for a minute, and we'll take a look at 13. Okay, so for 13, I could get a 0 in the numerator. Here, what I write 2. When 3x plus 1 equals 0, well, that's when x equals negative 1/3, right? Move the 1 over, divide by 3. That's when we'd get 0 over whatever 4 times negative 1/3 plus 2 is. So some fraction, some number, but whatever the denominator is, that's going to be 0 over a number, so the function would be equal to 0. In other words, we just found the x-intercept. So that's not a problem. That's not a problem as far as the domain. I mean, there's a range issue there, and we're going to look at that more in chapter 3. But the domain issue here is we got to know when does that denominator equal 0. So that would be when does 4x plus 2 equal 0. So I'm going to subtract 2 and then divide by 4. So when x equals negative 1/2, that's not in the domain. That's what would give me 0, right? 4 times negative 1/2 plus 2 would be negative 2 plus 2, which is 0. Can't have that. So for that domain, if that function, the domain would not include negative 1/2. Everything else, but not 1/2. Now, the other question you had, does the numerator affect the domain? Well, number 15 is a situation like this, and I'm going to ask you something like this on, if it's not the next exam, it's going to be it's going to be next quiz. It's going to be in the next exam. So whoops, I do have a question like that here. I got to undo what I just did. Let's delete that. Let me stop it for a minute. So for this numerator, for number 15, there's two things. I see I have a square root, so I can't take the square root of a negative number. So I'm going to ask myself, when does x equal, when is, well, actually, it's not equal to 0. I want to know when it's greater than 0. Because it's in the numerator, if I substitute in 0, I'm going to get the square root of 4, which is fine. So when is this equal greater than 0? So x has to be greater than negative 4. So that's a domain limitation for this function. Now the other domain limitation is from the denominator. I got to ask myself, when does x minus 4 equal 0, that denominator? So that's when x equals 4. It's a problem. So what's the domain of this function? It's going to go from negative 4 up to 4, and it's open at negative 4 because it's okay if this is 0. Actually, it can be closed at negative 4, can it? Greater than or equal to 0. Because it could be 0, because I can just take the square root of 0 is not a problem. In the numerator is not the problem. So yeah, I misspoke there. So it's from -4 up till 4, but I've got to skip over 4, positive 4, because that's where that denominator is equal to 0. And then I can say 4 to infinity. Okay, so that would be the domain of that. So you got to take both pieces. In this case, you take the numerator and the denominator. The other question you asked was about factoring. So looking at number 17, if I have x minus 3 over x squared plus 9x minus 22, the 3 on top is not a problem. What we got to do is decide when is that denominator equal to 0. And I know you did this back in an earlier class, an earlier course. That factors to x and x, and then let's see, 2 times 11 is 22, and 11 minus 2 is positive 9, so we know that factors this way. So x can't be equal to negative 11, x can't be equal to 2, because that would give me zeros in the denominator. So that's when it's these 3 terms. As far as, and then you can write that interval. I think I would, just to make sure that you catch this, what if I had, I'm making this one up, 3 over x squared minus 4? Well, that's a difference of 2 squares. When's that equal to 0? If you wanted to factor it, you would think about x plus 2 times x minus 2. So x can't be equal to negative 2, x can't be equal to positive 2. Because when x is negative 2, that's 0. When x is equal to positive 2, that one's 0, right? So it can't be that. So we'd have that. Now, sometime you're going to be given this. What if I had 3 over x squared minus 2x? When is that equal to 0? Well, I can factor out an x out of that. So x minus 2. So x can't be 0, because when x equals, so then I got to ask myself, when does x equal 0? Well, when x equals 0. And when does negative 2, x minus 2 equal 0? Well, x equals positive 2. So x couldn't be 0, x can't be positive 2. Okay, so there's all kinds of factoring you can do that I'm sure you've seen before. All right. Now, the other thing I'll point out, these are from section 4, and what you got to worry about when you're dealing with composite functions, you can do some algebra and get rid of some stuff, but the original domain limitations never go away. They're always there. So for 33, I've got 1 over the square root of x. Well, I can't divide by 0, and it can't be equal to 0 here, because that would be 1 over 0. So that domain would have to be that x is greater than 0. Okay, so that domain's still there. If I find m of p of x, I'm going to drop in that 1 over x squared. And this doesn't have any domain limitations, right? There's no way I can get a square root of a negative number and I'm not dividing by 0. So what we're going to do is we're going to drop in that 1 over the square root of x squared minus 4 into our m of p of x. That's right. And algebraically, we could do square that fraction and we could get 1 over x minus 4. If I just consider that, that would tell me that x can't be equal to 0, but it could be anything else. But remember this original domain limitation? That holds, that doesn't go away. And if you were to graph, in Desmos, if you were to graph this as a y function and graph, then have y, maybe call this like g equals, and then f equals, and then in y3 do f of g of x, it would not graph the result from 0 on, or it would only graph from when x is greater than 0. That domain holds. Check it out. Okay, so that holds no matter what, and then it's just a matter of doing the algebra to get the answers. If you want to look at some more of these, give a yell. You can also look at certainly for the odd numbered exercises, you can look at the detailed solutions. And want to have some questions answered live, grab a Zoom time.